this last video, I want to just kind of go over graphing and grid spacing and axis limits, and both in our bounds and our increments, and how to adjust those accordingly to make sure that your data is displaying properly. And so we've got on this third Excel spreadsheet here in the graphing demo, we're looking at 3 different experimental data series. So for experiment 1, we compare weir width and fluid density. And so we are taking these 2 parameters, holding them constant, and then by the weir height, we are looking at the flow rate that occurs. And so we kind of want to look at the trends that are happening with our data. So I've graphed this here in this first graph. So I've got my green diamonds here representing each of my points. And so currently, if we go in and look at our axes, so we've got a bunch of zeros that shouldn't be there for our numbers. And so we can go in and look at potentially taking this down to 3 decimal places, but we want to really look at our axis options, because should we be working in increments of 0.02 meters cubed per second, or should we be adjusting this into something that works better for our data set so that they occur within our minor or major grid lines? So I want to start adding our minor and major grid lines. So we've got our major here. And so with our grid lines, I'm going to add our minor grid lines so we know where our data points are fitting here. And if I zoom into this, really look at my graph here, so we see that the data points still aren't exactly on a single grid line here. And so what we may want to think about is adjusting our bounds. So instead of, like I said, going from 0 to 0.16, we may want to think about taking our bounds to 0.20. And so now we see that we've increased our ordinate axis to go all the way up to 0.20, but we also want to look at our units for our major and minor grid lines. So maybe here, our major, we want to go in, instead of increments of 0.02, going in increments of 0.05, so that our minor grid lines occur, so that our data points also occur in between or on every single data point that we have. So now our data points, it's very easy to interpret the data here, looking at where they fall. So here at 0.4, for a weir height of 0.4 meters, you know, or can interpret that this point is at 0.015, or pretty close to it, because it falls directly between my 0.2 and 0.02 and 0.01 increment here. And again, now we can adjust our number to only have 2 decimal places on our ordinate axis, so it becomes very easy to read. So let's kind of look at our second graph here, where we are comparing our weir height and fluid density held constant. And so we're looking at the weir width against the flow rate that is occurring. And again, we've got some increments here, so we're moving in 0.01 as our major increments on our ordinate for our flow rate. And so maybe we want to leave this here as we've got in 0.02 on the bottom for our major increments. And so maybe we want to, again, go and adjust these, because we've got one that falls on a line here but falls in between here, another on the line here in between here. So this one looks like it almost falls dead center. So maybe we want to make these points fit our data a little bit for our grid lines. So again, adding our minor grid lines. Where does our data fall and how much interpretation has to go into this? And so we're seeing that our data points aren't necessarily fitting exactly between 2 of our minor grid lines, so we need to adjust our axes to better interpret our data. So let's go ahead and start with our abscissa, or our horizontal bounds. So I'm going to click on my axis here, so that when I look at my format axis, I get my window, I'm going to go to the little bar chart area, axis options, and look at the bounds. And so here we may again want to adjust, so we're going to 0.2 for our weir width. So now when we adjust this, our units for our major grid lines become 0.05. And so now our minor grid lines at 0.01 allow our data points to fall exactly on a minor grid line, which makes it easier to interpret for the abscissa. Now looking at the flow rate, so let's look at our ordinate axis. What are our bounds here? And instead of stopping at 0.07, causing our major increments to be 0.01, we could say we want to go to 0.1. And then maybe we don't want such tight major increments, so we can up this to 0.025. So our minor increments are 0.005 meters cubed per second, which declutters our plot a little, but also allows our data points to either fall directly on a line or directly in between a line here for better interpretation of our physical data. So both of these look like they are pretty linear, or somewhere in the linear, or maybe a slight curve here in some of our data for our relationships. And it looks like in this one we may have a linear relationship, but if we look at our bounds for our third plot, when we're holding weir height and weir width held constant, now we're looking at our fluid density, so our kilograms per meters cubed, and our flow rate, so meters cubed per second. Our interpretation here is that we may have a linear increase based on fluid density and flow rate, but looking at our increments are really tiny. And so we need to adjust our bounds, so we should start at 0. And when we start at 0, all automatically, we start seeing that our data doesn't necessarily change much by adjusting that. And then the other thing we want to add are our minor and major grid lines. For looking at data interpretation, and our triangles somewhat fall between, but we may want to adjust our fluid density. So we see here that everything is compacted between about 600 and 1200. So we could go to our bounds on our abscissa. Again, looking at our axis options, and maybe we want to start at 500 or even 600. And then looking at that, so now a bunch of our data points fall pretty close. Here for our abscissa, we can interpret pretty regularly between major grid lines of 100, minor grid lines of every 20 kilograms per meters cubed. And then for our flow rate, then we would want to look at how we can maybe be a little better here. And so our maximum goes to 0.02 meters cubed per second, but we want to increase our major to occur 0.005, lessen how many grid lines there are, so we have some good interpretation. But now we notice that that linear trend may not exist, that there's really no difference between the flow rate based on the fluid density in our weirs. And so you want to make sure that your bounds and your major and minor increments are easily to interpret between and can be used to really help describe what is occurring in your plots. So that's just some added information on properly plotting and ensuring that your graphs are easy to interpret and explain the data appropriately. Next, we'll move on to trend lines, and that video will be up shortly.